Hi, my name is Sam Perrin. I'm a researcher with the Norwegian University of Science and Technology. I work for the Museum of Natural History here and the Centre for Biodiversity Dynamics. Now, I work on the ODYSSEUS Project, and I'm here today to tell you a little bit about that project. It concerns climate change, the effects that will have on the driving northward of invasive species, and what that means for the future of freshwater ecosystems, and of course what we're going to do about it. So, we all know climate change is happening. The planet is warming in certain areas, and it's warming in the subarctic and Arctic faster than in most areas. They're predicting a rise of 2.5 degrees over the next 50 years. Now, what that means is that a lot of species that previously weren't able to make it into certain ecosystems because it was perhaps too cold for them can now enter ecosystems that aren't used to them at all, that are completely naive to these species. These invasive species can then outcompete or prey on local species, in some cases changing entire habitat structures and food webs. The two examples I've used here, which I study in the ODYSSEUS Project, are the northern pike and the European perch. Now, whilst that is one negative effect of warming temperatures, the other is that certain species, such as, again, the species I'm studying here, the Arctic char and the brown trout, have less suitable habitat space. They are restricted in certain areas where the temperature becomes too warm for them. Reproduction goes down, and you can even potentially have local extinctions of these species. Now, local extinctions are okay if you have other lakes around which have persistent populations. That's what a metapopulation is, a collection of populations in the same area that are connected to each other. Now, if you have higher connectivity, it makes it easier for a metapopulation to persist. For instance, if you see down here, for instance, perhaps a species in this lake goes extinct. However, you've got these two lakes here which have populations of that species which can replenish it later. So higher levels of connectivity between populations leads to a metapopulation being able to persist more easily. This is especially important in freshwater ecosystems, this concept of connectivity. Because, for instance, if you're a bird, there's a ton of different ways you can get from one lake to another, if you're a wetland bird, for instance. However, a fish, of course, only has one pathway between two lakes. So, barriers to connectivity have been established by tons of humans in the past. We've put up dams, we've put up river structures, roads, which cut off access from fish from one lake to another. And there's been a great movement lately across Europe where a lot of these dams have been taken down. However, whilst that seems like a great idea, the fact is that whilst that does allow some native species to persist, it also lets invasive species in. And that's the crux of our project. That's why it's called ODYSSEUS. It's supposed to mirror the journey that Odysseus went on between Scylla and Charybdis, the rock and the hard place. What do? Do we let invasive species in and hope that those native species can persist when we increase connectivity? Or do we have to keep those dams, those culverts in place? Because the effects of the invasive species will be more negative than any effect of warming temperatures. So, what we're aiming to do is to come up with a management tool for end users, wildlife conservationists, people who work in freshwater institutes. So, for instance, if you have this red stripe here representing a dam, we want to be able to tell those people through the use of this tool if we're going to have negative or positive impacts on your freshwater ecosystem and your fish community if you destroy that dam. And I'll show you a little bit more about how we're planning to do that in future videos. Thanks for your time.